Guys, welcome. Okay, yes, the voice is clear now, right? Chalo, so we are going to continue. Very good evening. Okay, guys, so we are going to start the practice, and there are a few more questions that I want you all to do. So that's why we are here, and we are going to practice those questions. Right, so first of all, let me just quickly inform you all key for checking out whatever I share on the community, you have to follow me on the Unacademy in the CSIR-UGC NET category. There's a lot of important things like the links to the class, the DPPs, which are being shared on the community. So please see them. All right. And from tomorrow, that is 1st of June, from tomorrow, we are starting a new Battle of Polls, that is every day 6 p.m. we are going to have the question practice on topics like reaction mechanism. Tomorrow we are starting on reaction mechanism. Then we have the reactive intermediates. Then we have the reactive intermediates. Along with that, we also have the coordination, chemical bonding, stereochemistry, and heterocyclic. All right, all of these topics are there. So we are going to do the question practice on all of these topics. These are all free for everyone so that you can join and start practicing with us. Also, guys, important thing, tomorrow 5 p.m. we start a new Plus course. Plus is a paid platform, as you know already, right? And this is a course on spectroscopy, concept and practice course on spectroscopy, and which is going to include both the organic as well as inorganic topics, right? And if you want to join an Academy Plus, do so by before today midnight so that you can you can join within the existing prices. From tomorrow the price is going to hike by 20%. All right, and by using the code Jagriti S Live, you are going to get 10% off in the existing price only. Okay, so yes, these are the existing prices of an Academy Iconic as well as Plus subscription. By using the code within this also you're going to get the 10% off. All right, okay everyone, so let's begin quickly without any delay. Now plenty of important questions which I think are good and they might be asked in your exam. So the first thing is, see, all the questions are not going to be previous year questions. Okay, so it's not necessary you have all the MCQs. Let's say I'm asking you, this is a molecule. All right. What is your major product? All right. So what is going to be your major product for the following reaction? Yes, guys, you can answer in the live chat. What do you think is the correct answer for this question? Yes. So what is happening over here? What is this molecule that I have given you? Alright, this is your hexamethyl diacetyl amide. Okay, so this is your basically HMDA molecule. This is the bulky base. Yes. And what is the bulky base going to do? It is going to take away the readily available proton. Alright, and if it takes away a proton from the methyl group, what happens is you are having a negative charge on the methyl. Yes. Now you have a negative charge. Okay. Yes, this is your HMDS. Sorry. So negative charge on the methyl could be stabilized into the cyanide also. It could be stabilized into the pyridine. Alright, both ways it is stable. So if I draw this resonating structure, it is okay. As well as if I write this resonating, then also it would be correct because the resonance could go into the cyanide group as well. Like this. Okay. So the carbanion at this position is very stable, and this reaction is just like your alkylation of enolate. Okay. And what do you have? You have diethyl carbonate. You have diethyl carbonate in this way. Now the toxic group gets removed and your option number C. Yes, very good. Now let's move onwards and do next question. Alright. So what could be your product in the presence of acid? Yes, guys, what do you think is the correct answer? Question. Right, what do you say? Should we discuss? Okay, कोई बात नहीं. Let's discuss this question. All right, no problem. Let's discuss this question. It's actually very direct. See, what could happen? You're having the alcohol. Voice is low. अभी ठीक है? Yes. So you are having this alcoholic group over here. It's going to take away this proton and it's going to turn into this carbocation by the loss of the, let's say directly removing the H2O molecule from here. Alright, so it's going to give you this carbocation like this. What is bound to happen? This bond could migrate over here. Alright, your furan molecule can directly attack over this carbon, but that is not going to lead to any of these products. Okay, so that is why what we do is we try to shift the double bond over there like this, and we generate a positive charge on this carbon. So now the furan using its electron pair could attack from the third position. Okay, and if it does so from the third position, right from here, if it is doing so, how many membered ring will form? 1, 2, 3, 4, 5, and 6. Alright, so here the attack will take place. You already have a 6-membered ring above. Yes, you already have a 6-membered ring above. Here the attack is taking place, so positive charge is now fulfilled. But since the attack was on the third carbon, so you see here this carbon was already connected. You know, this carbon, it is already connected to the furan. From the third position it has attacked. This is how it is going to be. There is a double bond and ye ho gaya hai onium ion like this. Okay, now what happens? Now a proton from here could be lost to regain the aromaticity, and the product is option number B. All right. Yes, now it makes sense. Okay. All right, chalo. We move on to the next question then. Question number 3, let's say. Very direct and simple, this one. HNO3, H2SO4, what's going to happen to this molecule? Very direct question. Oh, sorry. Uh, all right. Which one you think is the correct answer? All right. Absolutely. So, see, we are talking about the nitration reaction. Nitration reaction kya hai? It's an electrophilic aromatic substitution reaction. So definitely it is going to look for the electron rich ring. The ring must be electron rich to be able to do this reaction. Pyridine ring is not electron rich at all. Benzene ring is, right? So benzene ring is going to have the electrophilic attack, alright. But what is going to be the position? The pyridine ring has a minus R and a minus I effect, isn't it? So what will happen? It is going to direct the nitro electrophile into the meta position. Okay. So this is your meta substitution going to take place. So meta directing as well as deactivating group pyridine is. So D is your answer. Yes, Vishnu, good evening. So from tomorrow, Battle of Pole is starting. All right, informed everywhere. Good evening, guys. Good evening. Welcome. All right. So what is the major product over here once again? Yes, very good, all of you guys. All right, everyone has answered. Yes. Okay, chalo. Let's discuss. All right, let's discuss what's going on. So, first of all, guys, in the presence of a Lewis acid, that is your aluminium over here, what is going to happen? You're going to get the allylic cation. You are going to get the allylic cation, right? And the indole molecule is going to attack from the third position, right? Positive charge over here, CH2PH, like this. Okay, nitrogen got a positive charge. And then what will happen, guys? Since there is no hydrogen over here, so we cannot lose a proton and just regain the aromaticity just like that. So what you have to do is one of the alkyl group should migrate. Yes. So this is your allylic and this is benzylic, which is more electron rich. Benzylic is more electron rich, is going to migrate better, and that is why what do you have is the benzyl group has migrated. You have answer as option number C, isn't it? The benzyl group is going to migrate. So first of all, you're going to still get a carbocation. Let's write it over here. All right. So the benzyl group has migrated. This is what you have, and the positive charge on nitrogen is not there, but this carbon got a positive charge. So lose a proton from this side. Okay, and C is going to be your correct answer. All right, better migration of the benzyl than the allyl. Okay, next question number 5. Let's see. CHCHO, HCH2Cl. All right, K2CO3. What is the major product? Absolutely not. No, no, Deepika, these are not PYQs. New questions. These are all different questions, not PYQs of CSIR net or GATE. Um, okay, so sorry. Yes, so this is your A, B, C, and D. A and D are also same, is it? Just a second. All right, so in the first condition, you also have a slightly basic condition. Let's say you are having a pyridine. Reconsider your answer, guys. Yes, Sushmita, now also can't hear properly. Please once refresh. All right. See, what happens in this question? In the first step, I have provided you basic condition also. So what can you think of? Okay, very well. What can you think of over here? Yes, Vishnu, absolutely. This is option number C. Yes, no. So see what happens is Yes, Yogesh, you can remove this proton, no problem in that. Yes, you can remove this proton. Also, let's say the CH3, which is given over here, right? So you can have the pyridine, you can have OH minus, you can have NaOMe methoxy, all right? You can have NaH, all right? So what will happen is, all right? So what will happen is the CH3 is also an acidic proton over here. Why? Let's say I have removed this proton, no problem. But since there is a nitro group in which it can do resonance, ये देखो CH2 minus है, right? So it can do resonance over here in this way, and that is why the proton of the methyl is acidic. Alright? So you can say you are writing this kind of a molecule. That will be correct. CH2 minus NO2. And even if let's say you are having the bi-anion like this, let's say you're having two anions, you know which is going to react first. Alright, on the PHCHO, it's going to be your CH2 molecule, right? So it's going to give you an aldol type reaction. Let's write in the next slide, guys. Okay. And also there is one more possibility. What happens is in this molecule, where you are having these two groups at a very close proximity. Alright, ये nitro है और ये methyl है, very close proximity. What happens is the oxygen can as it is take away this proton. Alright, it can do so, take away this proton, and the negative charge, the electron density is moving over to the nitrogen. What just happened? You get a CH2. Alright, you get a CH2 double bond. This carbon, single bond carbon, double bond nitrogen, OH and O minus. Positive charge on nitrogen. This is also possible. Okay, this is also possible over here. Now what? Now you have PHCHO in this way. Alright, now you can move the bonds in this direction, and directly, let's say, the attack on the carbonyl takes place. You are having the aldol type reaction. You are having the aldol type reaction over here. ये हो गया है NOH double bond O, still a positive charge over here, double bond over here, CH2 OH and pH, right? So this is your reaction which is going to take place, right? And what will happen next, guys? In the presence of, all right, the O minus, this oxygen can drive the reaction forward once again. How? ठीक है, let's say जो ये वाला nitro है हमारा, let's say this OH bond is going to fall over here once again. All right, या फिर एक काम करो, let's write the structure once again. What's going to happen? This is your CH2. This oxygen, this OH is, let's say, doing tautomerism. So let's just write this CH2 double bond. Here O, and over here O minus once again, right? One more carbon, pH and OH. Alright, so this O minus can do resonance in this way so that the bond is moving and the OH can eliminate. You will get CH2, nitro molecule. This is O minus as it is. Alright, so maybe I have just done one step directly, right? ये double bond इधर कैसे आया? ये वाला जो double bond है, how is this double bond coming over here? By doing resonance, right? Just like that, you can just remove this CH2 proton, okay, and deprotonate this. ये यहाँ से एक proton हटा दो. Let's say you have this one hydrogen over here, okay, and this oxygen also takes away a proton, becomes OH या फिर O minus, whichever you prefer, in the presence of a base. So from this intermediate आपको directly क्या मिल जाएगा? Alpha beta unsaturated compound like this. ठीक है, you can do this reaction. Now what? Now you are having one more double bond over here. Now you have in the basic condition PHCH2Cl. So basically it's nothing. Some nucleophile is going to attack over CH2, Cl eliminates. Who is left? Which nucleophilic group is left? So you have two types of hydrogens in the molecule, two types of nitrogens in the molecule, right? You have a pyridine type nitrogen whose lone pair is available, but once it attacks, the ring is going to become anti-aromatic, right? Also, the pyrrole type nitrogen whose lone pair is also available and it can easily lose a proton after the reaction. So here the PHCH2 is going to attack and the ring is still aromatic. Okay, so this is what you have. This is your product, option number C, this one. Let's do one more simple question. Question number 6. Now this is a very simple question, guys. Have two chlorines in the molecule. Alright, so what is going to be the major product in this case? Alright, this is it. What is your correct answer? Yes, very simple and direct question. Yeah, what has happened in this molecule? Simple nucleophilic aromatic substitution, isn't it? Yes, so there is a nucleophile over here, nitrogen having a lone pair, it's going to attack on such a position that brings the electron density on nitrogen. Alright, so the nucleophile is going to attack on such a position. Here you have two chlorines, right? So one of the chlorine is on the benzene ring, which is less, which is electron rich, not going to invite the nucleophile. And this ring is going to invite the nucleophile, two pyridine type nitrogens over here. This is what you get. Cl is very simply replaced. Yes, yes, Yogesh, little child are not studying the nucleophilic aromatic substitution. I have a little child, I know. So, C is your correct answer. Now, moving onward. All right. Okay. So, or let's say, I'm just asking you what is B. All right, guys. So, are we done? Right, guys. Very simple question. This is. Let's quickly do this, and then we move onwards to more important questions. Yes, absolutely, Yogesh. LDA है यहाँ पे. All right. First, proton removal. From where are you going to remove the proton? Yes. All right. ठीक है. Enough hint. जल्दी से बता दो. Okay. So the answer will be option number. All right. So what are we doing, guys? First of all, LDA. LDA is going to remove the proton from this side. ये हो गया lithium. And here you have the diisopropyl groups over here. So you'll have the amine removal, and this is where the ortholithiation is going to take place. Lithium है यहाँ पे, right? Now this is a more acidic proton, that is why the ortholithiation takes place on this side because of the minus R minus I effect of bromine. And after that, the SN2 attack will take place from the less hindered side. So, alright, you are going to first of all get option number A. This is correct. This first product is option number A. This is alright. Now, after that, let's say we have already formed this option number A. From here, you have butyl lithium. So, lithium and bromide are going to, this butane and bromide are going to eliminate halogen exchange from the metal. Yes, right? And there's a nucleophile methyl, so you are supposed to get methyl over here, just that. Okay, very, very simple question. Just the number of steps are more. This question is very, very simple, isn't it? LDA removing the proton, the more acidic proton. See, here also you can do the ortholithiation, but no, more acidic proton this side. Okay. Then substitution from the less hindered side, allylic substitution. Okay. Followed by metal halogen exchange, followed by the nucleophilic attack on the methyl iodide. This is your product. Okay, we now move onwards to question number 8. Let's see, plenty of important questions we are doing today. You have cyclohexanone and a base. What is going to be the major product? All right, is it done? let's see. So guys, what would you do first of all, looking at the looking at the positions where the atoms are already present? Yes, so this nitrogen is present on the third carbon to the pyridine. So A तो वैसे भी नहीं हो सकता. Yes, Vishnu, A and C are not possible. How is it so? It is present on the third position, and in the presence of a ketone, what is it going to form? Something like this. Yes, let's say something like this. And this is what? Imine. Also, in the presence of a base, what does it give you? Imine on the in the presence of a base is going to give you enamine. Yes or no? Yes. Yes, yes. हाँ, इसमें एक डबल बॉन्ड आएगा. Just like A only, डबल बॉन्ड नहीं ड्रॉ किया मैंने, but yes. Now what will happen is you have the enamine. मतलब कि ये रहा. All right. So enamine is a nucleophilic species. It can do the addition elimination mechanism, right? Enamine can do the addition elimination mechanism. A double bond over here, nitrogen gets a positive charge. So the Cl minus is going to eliminate from this side. Okay, that gives you. All right, so Cl minus eliminates, you get the pyridine molecule. And nitrogen still has a positive charge, so one proton eliminates from this side, and you are going to get this molecule, option number B. ठीक है. SNAR हो सकता है सेकंड पोजीशन पे, यहाँ पे हो सकता है. राइट. अच्छा, आपने सोचा कि आप पहले इनोलाइजेशन कर दो. First you do the enolization in the from this ketone, and you attack it from here, and then you form the. See, both the mechanisms will give you the same thing, Vishnu, isn't it? Let's say you are doing the enolization first, or let's say O minus होगा base के presence में. All right, let's say you got this. So from here, let's say even if you are doing this SNAR mechanism, then also the connectivity will still be the same because NH2 can react with the carbonyl only, right? Okay. There is no double bond, that's why. अच्छा ठीक है, कोई बात नहीं. But yes, you can see the bond connectivity. That is also going to give you a hint. Why NH2 will always be placed on the third position to pyridine N? Yes, Shushmita, see, actually the molecule is originally like this. We have not made the molecule, isn't it? It is already given to us like this. And if you're asking that why is it always the case? No, this is not always the case. You also have 2-aminopyridine. And how do you get the 2-aminopyridine? You get this by the Shishy-Babin reaction, isn't it? Yes, right? Okay, all right. So yes, this is not given over here. So if you are saying कि ये third position पे है इसीलिए हम ये product देख रहे हैं, absolutely that is what we are doing, and we are cancelling out A and C. Yes, you are correct. Okay, so let's move onwards to this next question. All right. All right, guys, try this out. Really nice question. All right, very, very important question. Very nice question this is. Let's see. All right. Is it too difficult? Not doable? What do you say? Yes, so the question is still here. You also have acid and heat. Yes, everyone. So, what's the reaction which is taking place over here? Methyl substituents. Let me just check once. No. No, Vishnu, it's like this only. These are the correct options. Okay, ये जो ester group है ना, this CO2Me, this is on the third position with respect to nitrogen, written like this. Okay, so tell me what is going to happen in the presence of HNO2, nitrous acid. क्या होगा guys? You got a free amine and then you got the HNO2. What is going to happen? Absolutely, you're going to get the diazonium. You are going to get the diazonium like this. But anything else possible with the molecule now? You have got the diazonium, you have a base. What is this base going to do? Yes, so you have a carbonyl. Is the base going to make the attack possible from this carbon or from this carbon? Which carbon is going to attack the diazonium? Yes, guys, according to you, what should happen? This is a more acidic proton, the middle one. Absolutely, yes. So we are writing, let's say we have got O minus double bond, internal double bond, because ये जो proton है, this is close to two carbonyl groups, right? So one methyl, one CO2Me in this way. All right. Now this O minus is going to attack in this O minus. ये जो enolate है यहाँ से attack करेगा. Going to connect from this side. Attacks on this nitrogen, bond opens up. What do you get? N, double bond N now. Rest of the molecule is as it is. Okay, यहाँ पे N और carbon, right? So which carbon? This carbon. New bond has formed. CO2Me and yes, what else do you have over here? One methyl, one CO2Me, one COCH3. This is what you have. Yes or no? All right. Now, see, this is a typical step over here, which maybe you are not able to imagine. Sometimes not possible to do so. ठीक है, ये CH3 हो गया as it is. Now what happens is there is a base OH minus. The base is going to attack over this carbonyl carbon and the bond is going to shift like this. ये यहाँ आ गया. Okay, a little bit of a different step. N, this got NH, alright, got a proton. Another N got a double bond like this, and the whole carbonyl part, ये वाला जो part है ना, this part is moving away. Alright, you get the CH3 COH, acetic acid निकल गया, and CO2Me. This is what you have got. Okay, so ये थोड़ा सा different है. Now what do you see guys? Now you see ये वही चीज है जो हमें मिलती है Fischer-Indole synthesis में. Yes or no? You can do the 3,3 sigma tropic reaction now. 1, 2, 3, and let's say from here you are going to remove a proton first of all. ठीक है, पहले यहाँ से remove करना पड़ेगा proton एक इस वाले methyl से, and then you will just be able to do this step 1, 2, 3. Yes, right? चलो, let's take it in the next slide. ओहो, slides खत्म हो गई है guys, इतने question कर लिए हमने. Let's do it over here then. So we ended up on this molecule. double bond. Let's say I'm writing COOMe over this side and this is your methyl. So a methyl can do tautomerism, and since you are going to have acid in the next step, अभी यहाँ पे acid और heat हो जाता है. Okay, NH, single bond NH, single bond, double bond methyl and CO2Me over here. Alright, now you can do this 3,3 sigma tropic reaction in the presence of heat. You are going to get the same mechanism that you get for the pyrrole formation. Okay, that is for the indole formation. Alright, so 1, 2, 3, or sorry, 1, 2, 3. Let's start from this middle one. 1, 2, 3. This is how it is going to be. Start from the middle. ये हो गया new bond formation in this way. Double bond NH, CO2Me, double bond NH on this side as well. So here it's going to lose a proton, and directly let's say I'm making the attack possible कि proton lose करने के बाद में this becomes NH2. Free NH2 is going to attack on the other carbon, right, and remove this NH group. So I am directly doing that step. ये लो, ये हाइड्रोजन यहाँ से लॉस हुआ. You got a double bond, then you got a NH2, but I am directly writing कि NH2 जो बनेगा, it's directly going to attack over the carbon which is connected to this nitrogen. NH2 free, CO2Me over here. Now this group is going to eliminate it in the presence of an acid, and you know what is going to result. मैं last में जो final product है वो मैं लिख रही हूँ. This is your final product, NHCHO. You get indole molecule substituted indole, CO2Me. Yes, Vishnu, that is why there is no substitution, no methyl substituent over here. Why? No methyl substituent over here because I have removed this by hydrolysis. ये रहा. ये जो part है, this we have removed when the OH minus had attacked over here. Alright, so yes, does it make sense? Yes, everyone? Okay, alright, yes, this is a very good question. You might get questions like these on the synthesis part. See, heterocyclic divided in two parts. One is the reaction part and one is the synthesis part. ठीक है, तो हमें दोनों अच्छे से करना है. All right. This one, yeah, sure. Done, all right. Okay, so yes, guys, basically another we have done 9 questions today. All of these questions were new questions, as you can see. सारे नए questions है. I want you all to note them down and practice from here. Also, now I am going to see you tomorrow. All right, and as you know, we are starting the Battle of Poles. Timing is 6 p.m. Special classes, and the new plus course we are starting 5 p.m. from tomorrow itself on spectroscopy. So yes, once again reminding you all, if you want to join through the code Jagriti S, you can do so, and it is going to give you a 10% off in the existing prices, right? And I will also inform you about the YouTube sessions for June very, very soon. Alright? Very soon I'll inform you on the Telegram group, on the Unacademy community, everywhere. Okay, so guys, bye everyone. Have a nice evening, all of you. We'll see you soon. Bye, guys. Take care, all of you.